Hello, my name is Carlos Kira, and for my science fair project, I did tumbling towers. Now, my abstract is, skyscrapers are impressive structures. What does it take to design a building so tall? Engineers use strong materials and innovate designs to push the limits of gravity and withstand forces. One type of force that can weaken a structure is a lateral shaking force, like that experienced during an earthquake. They need to be sure their design will withstand forces if it is in the earthquake alley. The shape the table will generate lateral movements, which will apply lateral forces to the model structure. So this is gonna be like the earthquake. I pull it back. Okay, so my question is, are short buildings more stable than tall buildings? Well, my hypothesis is, I believe that short buildings are more stable than tall buildings when challenged by lateral forces. Now my materials are Lego bricks, 2 flat Lego plates, 50 inches by 15 inches, a metric ruler, 2 15 inches by 15 inches wooden platforms, 4 small rubber balls, 2 inches in diameter, and 2 large rubber bands. So my procedure is, I had to cut the 2 boards, and they are 15 inches by 15 inches of plywood. Place the 2 pieces of wood on top of each other. Next, use a metric ruler, draw lines across the bottom piece of wood, starting with 1 centimeter, continuing to 10 centimeters. You will create a ruler, so measuring this displacement will be easier. Stretch your rubber bands around opposite ends of your boards. They should be at about 1 inch from the edge of the board on each side, so this is where I have it. Insert the rubber balls between the boards at each corner, placing them 5 centimeters from the edges. Now you have your shape table assembled. So these are the balls. Okay, so number 6, attach a large flat Lego mounting plate to the top of your shape table. So this is where you're going to put your buildings and make them stick. Number 7, start building your Lego buildings. We made 3 different buildings. You should use the same base pattern for each tower so the size of the tower's footprint does not change and only the height will be different. 8, measure the height of each tower in inches with a measuring stick. Write the height of each tower in a data table, such as 5, 10, and 15. Number 9, test each tower, place it in the center of the top surface of the shape table. Then you will pull the top layer of the shape table out of alignment, and then let it go to create a lateral shaking movement. This is going to substitute for an earthquake. Number 10, measure the distance in centimeters that you will pull the top layer away from the bottom layer. This is displacement. You will record this measurement in your data table. So we pull this out, and it's we're going to do 4, 7, and 10. Number 11, test each tower for increasing displacement values until you find out when the tower will fall. For this experiment, we use 4 centimeters, 7 centimeters, and 10 centimeters. Last, compare your results. So I did 3 trials. For the first trial, 5 inches, it didn't fall at all. For the other one, which is the 10 inches, it didn't fall at all for any of them. But then we got to the 15 inches, and it did fall, and I reported back 7 and 10 centimeters. Then we have trial 2. Now, it didn't fall at all when it was the 5 inch. But then, when it was the 10 inch, it fell when I reported back 10 centimeters. And for the last one, which was 15 inches, it fell when I reported back 7 and 10 centimeters. Now trial 3 is the exact same as trial 1, so it didn't fall at all for 5 inches. It didn't fall at all for 10 inches, but it did fall whenever we pulled it back 7 and 10 centimeters for the 15 inches. Can I have some volunteers? I'll take Kate and Lauren. So, this here. Alright, Lauren, so you're going to pull it back 4, make it line up 4, then the 7, and then the 10, when this each falls. Start off with 4. Now let go. Okay, now do 7. Now let go. I'll do 10. Now let go. So that didn't fall at all. So can I have 8, 10? Alright, pull it back 4, 7, and 10. Okay, let go. I'll do the 7. Let go. because of the 10. So this one is that child one. It didn't fall off. Now I will do the last one. Didn't fall. 7 didn't fall. Fell. So, what we found out is that taller buildings are less stable, and you should not use them. And my conclusion is, once I did my project, I concluded that taller buildings are more likely to fall than shorter buildings due to lateral forces. In my project, we used the same size base, but built 3 different heights of buildings. Not until we got to the tallest building did it fall, and the second and third lateral replacement. My hypothesis was correct. Now, a place I found this answer project is sciencebuddies.org. Thank you.